Data Preprocessing. Essential data cleaning and transformation for artificial intelligence. In this video, we will delve into the world of data preprocessing, a crucial step in preparing your data for artificial intelligence models. We will cover essential cleaning and transformation techniques that will help you unlock the full potential of your data. Why is data preprocessing so important? Firstly, it ensures data quality and reliability for artificial intelligence models. High-quality data leads to reliable insights and predictions. Secondly, it removes inconsistencies and handles missing values, which are common problems in real-world datasets. Thirdly, it improves model performance and accuracy. Clean and well-prepared data allows models to learn more effectively. Fourthly, it reduces training time and computational resources. Efficient data processing can save significant time and resources. Lastly, it standardizes data format for consistent processing, ensuring that your data is in the right format for your chosen models. Let's outline the main steps involved in data cleaning using Python. First, load and inspect the raw data. This initial step involves loading the dataset into a pandas data frame and examining its structure and contents. Next, remove duplicate entries. Duplicates can skew analysis, so we use the drop duplicates method in pandas to eliminate them. Then, handle missing values appropriately. Decide on a strategy to deal with missing values. You can use imputation techniques, like replacing missing values with the mean or median. After that, identify and handle outliers. Outliers can negatively affect model training. Box plots or scatter plots can help in identifying these values. Finally, validate data types and formats. Ensure that the data types of each column are correct for the intended analysis. Now let us discuss some advanced data cleaning techniques. First, string cleaning. Standardize text data by removing special characters, extra spaces, and inconsistent formatting. To standardize the string, convert text to lowercase and remove leading/trailing spaces. Then, use regular expressions to remove any non-word characters. Next, date formatting. Convert various date formats to a standardized date-time format for consistent processing. Use pandas to datetime function to convert date columns to a standard format. The format argument specifies the current format of the date. After that, category consolidation. Merge similar categories in standardized category names to reduce dimensionality. Use the replace function in pandas to merge similar categories into one. Lastly, value range validation. Ensure numerical values fall within expected ranges and handle invalid entries. Create a Boolean mask to filter rows where the value is within the specified range. Apply this mask to the data frame to keep only valid entries. Now let's look at different strategies for handling missing data. First, mean imputation. Replace missing values in a column with the mean of that column. The code replaces missing values in the column called call with its mean. Next, median imputation. Replace missing values with the median of the column. The code replaces missing values in the column called call with its median. After that, forward fill. Fill missing values with the value from the previous row. This method is useful in time series data. The code fills missing values using the forward fill method. Then interpolation. Estimate missing values using interpolation techniques, such as linear interpolation. The code uses linear interpolation to fill missing values. Finally, drop missing values. Remove rows containing missing values in a specified subset of columns. The code removes rows where there are missing values in the important underscore call column. Let's discuss data transformation techniques. First, feature aggregation. Combine multiple features into meaningful summary statistics. Aggregate quarterly sales data into total sales for the year. Next, dimensionality reduction. Reduce feature space while preserving important information. This can be achieved through techniques like principal component analysis or feature selection. After that, feature engineering. Create new features from existing ones to capture relationships. Create a price per unit feature by dividing the total price by the quantity. Then data type conversion. Convert features to appropriate data types for processing. Convert the date column to a date-time format. Convert the category column to the category data type. Now we will discuss about feature scaling methods. First, min-max scaling, also known as normalization. It scales features to a fixed range 0 to 1. It is best used when you need bounded values or data has a limited range. Here is the code snippet. From Preprocessing import min-max scalar. Scalar equals min-max scalar parenthesis. X underscore scaled equals scalar. Fit underscore transform parenthesis X parenthesis. Next is standard scaling or standardization. It transforms features to have zero mean and unit variance. It is ideal for algorithms that assume normally distributed data. Here is the code snippet. From Preprocessing import standard scalar. Scalar equals standard scalar parenthesis. X underscore scaled equals scalar. Fit underscore transform parenthesis X parenthesis. Next, robust scaling. It uses statistics that are robust to outliers. Preferred when data contains significant outliers or extreme values. From Preprocessing import robust scalar. Scalar equals robust scalar parenthesis. X underscore scaled equals scalar. Fit underscore transform parenthesis X parenthesis. Next, log transformation. It reduces skewness in data and handles varying scales of magnitude. Useful for right-skewed distributions. Import numpy as np. X underscore scaled equals input log 1p parenthesis X parenthesis. In this section, we will discuss about encoding categorical data. Let's start with label versus one-hot encoding. Label encoding assigns a unique integer to each category. One-hot encoding creates a binary column for each category. Here is an example. For the original value red, label encoded value is 0 and one-hot encoded value is 100. For the original value blue, label encoded value is 1 and one-hot encoded value is 010. For the original value green, label encoded value is 2 and one-hot encoded value is 001. Now let's discuss target encoding example. Target encoding replaces each category with the mean of the target variable for that category. Here is an example. For the category, target mean is 0.85 and encoded value is 0.85. For the category B, target mean is 0.42 and encoded value is 0.42. Now let's discuss different encoding techniques. First, label encoding. From Preprocessing import label encoder. LE equals label encoder parenthesis. DF bracket encoded bracket equals L fit underscore transform parenthesis DF bracket category bracket parenthesis. Second, one-hot encoding. From Preprocessing import one-hot encoder. OHE equals one-hot encoder parenthesis sparse equals false parenthesis. Encoded equals OHE fit underscore transform parenthesis DF bracket category double bracket parenthesis. Third, target encoding. Def target underscore encode parenthesis DF comma call comma target parenthesis colon. Means equals DF dot group by parenthesis call bracket target bracket. Mean parenthesis. Return DF bracket call bracket. Map parenthesis means parenthesis. Fourth, ordinal encoding. From Preprocessing import ordinal encoder. OE equals ordinal encoder. DF bracket encoded bracket equals O fit underscore transform parenthesis DF bracket category double bracket parenthesis. In this section, let's explore the best practices for data preprocessing. Firstly, data validation. Always validate data quality before and after preprocessing. Check for inconsistencies, outliers, and errors. Examples of data validation are: validate data types, check value ranges, and verify categorical values. Secondly, feature selection. Choose relevant features that contribute to model performance. Remove redundant or irrelevant features. Examples of feature selection are correlation analysis, feature importance, and domain expertise. Thirdly, data leakage. Prevent data leakage by applying pre-processing steps separately to training and test sets. Examples to prevent data leakage are split first, transform later, use pipelines and validate transformations. Fourthly, documentation. Document all pre-processing steps, parameters, and decisions for reproducibility and maintenance. Examples of documentation are record transformations, version control, and parameter tracking. Fifthly, automated pipelines. Create automated pre-processing pipelines for consistent and reproducible data transformation. Examples of automated pipelines are scikit-learn pipelines, custom transformers, and error handling. Lastly, performance impact. Monitor how pre-processing decisions affect model performance and computational resources. Examples of performance impact monitoring are benchmark results, memory usage, and processing time. Now let's see a complete pre-processing pipeline example. From sklearn.pipeline import pipeline. From sklearn.compose import column transformer. From sklearn.preprocessing import standard scalar. One hot encoder. From sklearn.impute import simple imputer. First, define numeric and categorical columns. Numeric underscore features equals bracket age, income, score bracket. Categorical underscore features equals bracket education, occupation bracket. Then create numeric pipeline. Numeric underscore pipeline equals pipeline parenthesis bracket parenthesis imputer comma simple imputer parenthesis strategy equals median parenthesis parenthesis scalar comma standard scalar parenthesis bracket parenthesis. Then create categorical pipeline. Categorical underscore pipeline equals pipeline parenthesis bracket parenthesis imputer comma simple imputer parenthesis strategy equals constant comma fill underscore value equals missing parenthesis one hot encoder parenthesis drop equals first comma sparse equals false parenthesis bracket parenthesis. Now combine pipelines. Preprocessor equals column transformer parenthesis bracket parenthesis numeric underscore pipeline comma numeric underscore features parenthesis categorical underscore pipeline comma categorical underscore features parenthesis bracket parenthesis. Finally, fit and transform data. X underscore processed equals preprocessor. Fit underscore transform parenthesis X parenthesis. Key benefits of using pipelines are ensures consistent pre-processing across training and testing data. Prevents data leakage during pre-processing steps. Simplifies the pre-processing workflow and reduces code complexity. Makes the pre-processing steps reproducible and maintainable. Integrates seamlessly with scikit-learn's cross-validation and model selection tools. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.